Welcome to the lesson titled Statistics in Excel. We're going to talk about correlation, regression and a little bit of t-testing. This picture shows you the people analytics levels. You start on level 1 with operational reporting, which is basically the visual reporting from a single system. Now, getting more in depth and combining that with exit information, saying, hey, we combine different information sources and then we actually see why people are leaving, that moves to advanced reporting. So with advanced reporting, you can start to create dashboards and you can start to create smart pivot tables that display information that you couldn't see before because you weren't able to connect those different systems. Now in this lesson, we'll take a look at advanced analytics. When we talk about advanced analytics, we think of a number of things, namely significance testing, correlations, and regressions. These terms have everything to do with the wall of Boudreaux. When HR starts to develop their HR analytics capabilities, they are usually quite good at the metrics, the benchmarks, the scorecards, and the surveys, but they find it really hard to get through the wall of Boudreaux. They find it hard to get into analytics. Why? Because as you already saw, you need to be able to work with Excel, with data exports, you need to be able to play around with the data, and you need to be able to do a correlation analysis, a regression analysis, and other different techniques that enable you to do actual analytics. Well, that's what we're going to talk about today. And as you can understand, it's going to be impossible to explain you everything about statistics in one single lesson. What I can do is I can give you all the tools you need, just like I said in the introduction of this module. I can give you all the tools you need for you to get going. And I'll explain you how to activate the built-in tools in Excel that enable you to do actual statistics in your Excel datasheet. Let's get started with a correlation analysis. I'm not going to dive too much into this, but a correlation is an association between two variables. It could implicate a causal relationship, but usually it's not a causal relationship. It is an indication of a predictive relationship, but it doesn't mean necessarily that there is a predictive relationship. And correlation is measured most commonly in Pearson's R, and that indicates a linear relationship. You also have a Spearman correlation coefficient. Depending on the kind of data that you have, you use different correlation coefficients. And in the course material, I'll give you a handy overview where you can find out what kind of variables and data you're working with, and then find out which analysis, which correlation analysis you actually need to do. Pearson's correlation coefficient only works on continuous variables compared to nominal variables, which are named variables, for example, male or female, that's nominal, and you have ordinal variables. In order to do a correlation analysis, you shouldn't have outliers in your data, so check for outliers. And your data needs to comply with the homoscedasticity criteria, which means that all the data is in a single pathway, a linear pathway. There's no cone shape or inverted cone shape in your data. Usually this is the case for your HR data, but I'll link to some extra resources in the course material. These 4 pictures show you why you shouldn't rely on data alone. All 4 pictures have the same mean, the same variance, the same correlation, and even the same regression line. However, the story that these data points tell you is very different. For example, picture 2, the top right corner, there's not a linear relationship in the dots that you see on screen. And for example, in picture 4, there's just one outlier and there's still a linear relationship according to the regression line. But in fact, if you just remove the one outlier, you have a very different model, and that's probably closer to the truth than the story that the regression line tells you. So be very careful, don't rely on data alone, combine data with your insights, with your knowledge about the organization, with your HR skills, so in the end it's data and insights together. The blue line in the pictures is the regression line. And when we talk about linear regression, we're talking about a line that provides an indication of the relationship between two variables. So as you see in the picture, there's a certain relationship between x and y, and that's characterized by the line that's drawn. That's the regression line. Linear regression relies on the sum of the least squared, and I'll show you how that looks later. And the formula usually is the constant, alpha, plus the beta, the slope of the line, times x. Now this is a nice overview of the relationship between age and pay. You see 5 people of 20, 25, 30, 35 and 40, and you see what they're paid. And can you, based on these data points, assume a relationship between age and pay? And to do that you can draw the regression line, which would look something like this. Now the line is drawn because it tries to create the least distance between all the data points and the line that's drawn. And that's done by taking the distance between the point and the line for each point and then squaring it, and that way the sum of the least squared is then in the end the line that's drawn. So it tries to optimize and find the line that fits the model best. Let's get started with data analysis in Excel. And before we start, we activate the Analysis Toolpack add-in, which has the basic statistical techniques to analyze data, all in Excel. For example, an ANOVA, an analysis of variance, a correlation analysis, t-tests, and the t-test is a test where you can measure the difference between two different variables. So if you have a whole list of individual scores on two different variables and you want to see, like, hey, do these two variables differ significantly from each other? And if they do, you can draw conclusions that there are indeed significant differences between two groups. Regression, and quite some more. The key test, for example. For even more advanced analysis, for example, multiple regressions, if that's the kind of analysis that you want to do, then you need to dive into SPSS is the easiest, or SAP or Stata, because those are the tools that enable you to do multiple regression analysis. For simple regression, Excel suffices. The data is attached below the video and we have 2 research questions. Your HR manager comes up to you and says, someone is complaining that juniors receive less training days than seniors. Is that correct? Is there a correlation between time at the company and training time? And my second question is there a difference in job satisfaction between people who left the organization and people who are still in the organization? Because if that's the case, then I know and I can tell the manager that we need to take better care of people because happier people stay longer.